okay? Whereas when you're dilating figures, and we talked about this last unit, when you dilate, you produce those similar figures, okay? So we are starting with transformations, and then we are going to get into congruence theorems, okay? Much like our similarity theorems, we have a whole different set for congruence, okay? So today we are splitting up the transformations. We're going to look at reflections, translations, and symmetry today. And then next class we're going to look at rotations and then spiraling them all together. Okay, so we found that this is the best way to split it up. Okay, our first thing that we're starting with is lines of symmetry. So lines of symmetry are imaginary lines that you imagine where you could fold the image in half and they would match exactly. Okay, so for letter A, you have a smiley face. How many lines of symmetry can you draw on a smiley face? One. Okay, and that would be right down the middle. Okay, there's only one way you can fold this smiley face where it's going to overlap and match exactly. Okay, you can't fold it the other way because the mouth would be over the eyes. Okay, so there's only one line of symmetry in a smiley face. Okay, letter B, you have a hexagon. We don't know if it's regular or not, meaning we don't know if all sides are congruent. We just know that it's a hexagon. So how many lines of symmetry does a hexagon have? 2. So you have your, is this hot dog fold? Hamburger. Hot dog? Hot dog fold and your hamburger fold. Okay, because we don't know whether all sides are congruent, okay, we can't say that it has 6 lines of symmetry. Okay, so at minimum, hexagons have 2 lines of symmetry. So smiley face had 1, hexagon has 2. Okay, letter C, a circle. How many lines of symmetry does a circle have? Infinite. Okay, so I'm not even going to try to draw infinite, but, you know, could go this way, this way. Oh my gosh, that's terrible. But over and over and over again. Okay, a rectangle, how many lines? 2, your hamburger and your hot dog fold. Okay, D is a little bit tougher. How many lines of symmetry are in D? 4. Okay, so I'm going to draw the 2 obvious ones. You have this one and this one. Are there more, though? Yes. Which one? The diagonal. The diagonal. So if I were to draw the diagonals, okay, and then rotate your paper, what's on top of this diagonal matches what's on the bottom of this diagonal, okay? And then my second diagonal. So we have 4. Okay, and letter E? None. 0. Questions on lines of symmetry? Okay, just make sure that you don't just think that it's hamburger and hot dog. Make sure you kind of rotate it and see if you could draw a different line of symmetry. Okay, so that way you don't miss any of them. Okay, a regular polygon with n number of sides has n lines of symmetry. So if it's a regular hexagon, how many lines of symmetry would it have? 6. If it's a regular octagon, how many lines of symmetry would it have? 8. Decagon? 10. I don't know any other ones. For example, a pentagon has how many lines of symmetry? 5. Okay, so that's a test question. That should be an easy one. Okay. Next page. Okay, jumping into our transformations. Okay, so example 1 says to translate the figure left 6 and up 8. Give the coordinates of the new point. Okay, who remembers? What do we call the figure that I start with? pre-image, and your transformed figure is called what? Your image. Okay. So let's start with listing our pre-image points. Where is A? 2, -3. Where is B? 2, -8. C? 9, oh, not 9. 8, -8. D? 8, -3. And last but not least, E? 5, -5. Very good. Okay. So those are our pre-image points. And now we are looking to create our image that has been translated left 6 and up 8. Left 6 is affecting what? X value. So I'm going X minus 6, and up 8 is? Y plus 8. Okay, so you might have something called coordinate notation. And for this problem, it would look like this. XY yields X minus 6, Y plus 8. So it's telling you for every X coordinate that you have, you're subtracting 6, and for every Y coordinate you have, you're adding 8. And that's going to make the new coordinate. So this coordinate matches your pre-image, and this coordinate matches your image. Okay, so just a reminder, left and right are affecting your X value, up and down is affecting your Y value. Okay, so where would A prime be? -4, 5. Where would B prime be? -4, 0. C prime? 2, 0. D prime? And E prime? -1, 3. Okay, so plot those points. Make sure you label them appropriately with the little tick marks. Okay, and you'll know that you plotted your points right if your figure looks the same, because they should be what? Congruent. Okay, questions on example 1? Okay. Example 2 says to describe each translation. Okay, so example 2 doesn't give you any of the coordinates. It doesn't give you the coordinate notation. Doesn't give you the rules and words. Okay, so it wants you to figure it out based off the graph. So from A to B, you know that you're looking at these 2 points, or these 2 figures. Okay, so pick a point, one in point A and one in point B, that correspond with each other, and figure out what translation was applied based off the coordinates. So if I'm going to pick the upper left, for example, okay, where is the upper left coordinate in A prime? For A prime, what is it?
2, 3.
The upper left coordinate? For A? Y'all gave me B.
You said A prime?
Oh, sorry, just A.
Oh.
Upper left of A. Negative 8 what? 8. Sorry about that. And B? 2, 3. Okay. So now we're looking at the upper left point in each of our shapes. We have negative 8, 8, and 2, 3. Okay, so if I were to write this in coordinate notation, I have x, y yields. Okay, what would be the rule that's associated with my x? How did I get from negative 8 to 2? Plus 10. And how did I get from 8 to 3 for my y value? Minus 5. So our rule would be x, y yields x plus 10, y minus 5. If I write this in words, what does that say? Right 10 and down 5. Okay, with the people in your group, do 2 and 3. Alright, what did we get for B? X, Y yields what? X plus 2, Y minus 6. In words, what's that mean? Right 2, down 6. Okay, from D to C, X, Y yields what? X minus 12, Y minus 1, and what does that mean? Left 12 and down 1. Any questions with coordinate notation? Awesome. Alright, three-dimensional figures can be made using translation. So if I take a square or a rectangle, for example, and I translate it through space, okay, I'm making a 3D figure, and what 3D figure is going to form out of a rectangle? A rectangular prism. If I take a circle and I move it through space, what 3D figure would form? A cylinder. If I take a square through space, what forms? A square. A cube. Well, depending on how far you translate it. True. Okay. So as you translate those figures, okay, you can make 3D shapes. So we're going to see what shape is made in example 3. So first plot these 4 points. -2, -2. -2, 1. 1, 1. And 1, -2. So connect the points in that order. What shape do we have? A square. Okay, it wants us to translate the figure 2 units to the right and 1 unit up. Okay, so you can either look at each of their coordinates, write a new coordinate, and plot it, or just take each point and go right 2, up 1. Right 2, up 1. Right 2, up 1. Right 2, up 1. Okay, so if I connect those points, I get my second square, and then I could make it a what? Cube or a rectangular prism, depending on the dimension. Okay, so that's just to see that when you translate a shape through space, okay, it does create 3D figures. Questions on example 3? Okay, moving right along then. Okay, example 4. This time you are not given a coordinate grid. Okay, it's strictly a word problem. You just have to do the mental math or write out. Okay, the vertices of triangle ABC are 1, 5, negative 3, 3, 5, negative 4. It is translated such that A prime is now at negative 4, 2. What are the new points for B prime and C prime? So right now I have A prime, which is at negative 4, 2. And my original A point was at 1, 5. So in words, what happened? Left 5 and down 3. Okay, so in coordinate notation, what does that look like? X minus 5, y minus 3. Okay, so I need to translate point B and point C. So B currently is at negative 3, 3. If I apply this coordinate notation to that, where is B prime going to be? Negative 8, 0. And where would C prime be? 0, negative 7. Questions on how to do that without a coordinate grid? Awesome. Okay. That is it for translations. That'll be no, you can go to the bathroom if you want. That will be as hard as it gets. Any questions on translations? Alright, reflections. Okay. Reflect the points A, B, and C across the x-axis and name the coordinates. Okay, so again, I want you to kind of get into the habit of circling and highlighting like we did with rotating triangles and rectangles around axes. Remember, we highlighted so we wouldn't make a mistake. So we're going across the x-axis. So when you reflect across the x-axis, what coordinate changes? Your y. And what does it become? Just opposite. So where would A prime be? B prime? And C prime? Very good. Okay, so now graph that. Okay, another way to reflect something across an axis is just to count how far away it is from the axis, and then do the same thing on the other side. So B is 2 away from the axis, so now we're going to make sure it's 2 away from the other direction. Okay, and what's the pattern here? What did we do to all of our coordinates? You change the sign of what? The y. X stays the same. Okay, so in coordinate notation, what would be the rule for a reflection across the x-axis? You would have xy yields what? Very good. X and then opposite y, or negative y. Because your x is staying the same always. The only thing that's changing is the sign of your y. Okay, when you reflect something across the y-axis, which coordinate changes? The x. So what would be the point of x prime? 2, 3, y prime? And z prime? Okay, plot your point. Okay, what is the pattern? Very good. Change sign of x coordinate, and what happens? Y stays the same. What would be the coordinate notation? Very good. So you would have to be able to identify, if it was multiple choice, let's say, and it would say, what is the coordinate notation of a reflection over the x-axis? You would have to be able to distinguish between the two of these and pick which one represents a reflection over the x-axis or the y-axis, or translated up 8, down 5, or up 8, right 2, whatever. Okay, so you have to be able to identify these coordinate notations. Alright, on to that. Okay, so we're going to be able to reflect over axes, over just like horizontal and vertical lines. For example, x equals 2, y equals 6. It's the same principle. And then the only time we will reflect over a line is if it's the parent function, which is just y equals x. Okay, and then we'll name the coordinates and do all that good stuff. Okay, so when you're reflecting over a line, it's a little bit harder than just counting. Okay, when you have y equals x, okay, what's another way I could say that? I could say y equals x, or I could say x equals y. Okay, so all you have to do is flip-flop them. So when you are reflecting over the line y equals x, your x and your y values just flip-flop. Okay, so r prime equals what? 6, negative 4. S prime equals what? 2, negative 1. T prime? Negative 1, negative 6. Because what I'm asking myself here is x equals what, and x equals y, which is 6. Then over here, I'm asking myself y equals what, and y equals x, which is negative 4. And that's why they just flip-flop. Okay, and then graph that for a second. Okay, what's our pattern? Very good. X and Y switch places or change places. So what would be, how would you write this in coordinate notation? Very good. Just flip-flops. XY yields YX. Okay, last two. Reflect the figure over K and then over M. What transformation results from the pre-image to the image? Okay, so this number 4 and 5 are examples across parallel lines. Okay, so if I reflect over K, I'll get something like so. And then if I take that image and reflect it over M, I get something like so. So it's asking what transformation results from the pre-image to the image. So from here to here, what kind of transformation does that look like? A translation what? Just down. Okay, so a double reflection across parallel lines looks like a translation. Okay, and then you can show the same thing with the pentagon, but my drawing skills are not very good. Okay, and then number 6 and 7, we are reflecting across perpendicular lines. Okay, so if I reflect over K and then M, what type of transformation looks like the pre-image to the image? So now from here to here, what does that look like? A rotation. And then you could draw the same thing over here. This one's a little bit trickier. Okay, so a double reflection across parallel lines is going to produce the translation, and a double reflection across perpendicular lines will produce a rotation. And that is where we are going to leave off, and then we'll pick up on rotations next time. Are there any questions on translations or reflections or symmetry? Nothing?